You see, this screen sharing from Hungary is difficult. I don't know why.
But you have such beautiful posters all the way from Hungary, especially the girls.
Thank you very much.
Thank you. Make it bigger, please. Bigger.
A little bit
bigger. Okay.
Yes.
The results.
Is it okay now?
Okay. Well, that's very, yeah, okay. I remember now, yeah.
All right, thank you. So I'm Louise, and I also work with the food administration team, with Zoltan Kovac and my other colleagues who had already presented. And I'm just going to talk a little bit about this study on meat, which is actually a preliminary study, because we are going to have the main experiment later on. But for now, we just wanted to have an idea in the direction in which to plan the experiment. So we want basically from regulatory point of view, well, we have a lot of meat products on the market in minced forms, and according to the regulations, the percentage of mixture should always be mixed, because for instance, in terms of religious significance, there are some religions that do not consume certain kind of meat. So and there are several methods to detect this kind of meat mixtures. Most of these methods are the conventional methods, and they have their drawbacks, such as like being slow and can be relatively expensive. So we thought that, okay, why not to try the Aquaphotomics approach, especially using some dilutions. So for now, we only explored 1% dilution, and what we did was we got meat samples. We got beef and then pork meat from the supermarket, and then we brought it to the laboratories. We minced them, and then we did a mixture concentrations to 6 different mixtures, ranging from 100% to 80% weight per weight of beef. And then we did a 1% weight per volume dilution. And then we used different extraction methods. That's one of the most important parts of the study, because we wanted to see whether which extraction method was the best. So we used we called it raw meat extraction method, and then we have the cooked meat extraction method, and we have the frozen meat extraction method. And I couldn't put some of the figures in the poster, but I can just show it here on my PC. And so for the raw meat extraction method, what we did was we just basically, after weighing the meat mixtures, we put them in a flask, added some distilled water, 200 milliliters, and we shook it, homogenized it, and then we filtered it with a filter size of with 1 millimeter per size. Yes, and then this was a crude method. We also developed another method with a frozen meat extraction method. This was very similar to the raw meat extraction method, but with this one, we kept the meat samples in the freezer for 2 days. And then when it was frozen, we defrosted it, and then we extracted it the same way with the frozen meat extraction. The last method we tried to develop was the cooked meat extraction method, which we wanted to see whether maybe when we cook the meat, more compounds can be extracted and can be used for this to detect mixture concentrations. So based on this, so from the stock solutions, we prepared a 1% weight per volume dilution from each stock solution of the different extraction methods. And then we did some multivariate data analysis. We scanned it first of all with Metri and NIR, with a benchtop spectrophotometer. And then we did some multivariate data analysis using PCA to kick out some outliers, and then we did some classifications at the wavelength range between 1,300 and 1,600 nanometers. Because of the wide concentration ranges we use, I decided to select 3 different concentrations to do some microgram plots out of them. And we could see from the results that we had some good classification accuracies. And even in the LDA classification plots, we could see some separation patterns, especially when the non-extracted meat was scanned. Yeah, so actually, we scanned both the minced meat that is not extracted, and then also the extracted and diluted meats. So what was very interesting for us was that we noticed that when we use the raw meat extraction method, we had better classification accuracies compared to when we used compared to when we scanned only the minced meat without extraction, which gave us an idea. I mean, which we were happy about, because it emphasized on the role of water in acting as a molecular mirror and helping us detect such mixture concentrations. So we also went ahead to do acagram plots, and we could see in the acagram plots that the hydrogen bonded water and then the no free water zones also contributed to the differentiation between 100%, 90%, and 80% meat mixtures. And this was true for the non-extracted meat and for the raw meat and frozen meat extraction. And in certain cases, we could even see some increasing patterns, like from 100 to 90 to 80. So, so we plan to expand this study further, reaching different meat samples as well, and then try another dilution levels as well. But for now, we concluded that we could get some good accuracies, and then the acograms also were very informative in determining these meat mixtures. Thank you.
Thank you, John Lewis. Very interesting.
Thank you.
Do we have questions or comments for John Lewis? Here, Pierre. John Lewis, do you see? Professor Hook, sorry.
John, nice to see you again.
Nice to see you too.
Yeah, it's a very nice and also very important work. Thank you for this very highly worthy contribution. I don't know if we last time had the chance to exchange, and I can't remember if I informed you that we had a European Union project on a very similar topic, which is already closed now. And our aim was to do the analysis through the packing material, through plastics. So this is my first question. Have you tried to do measurements through the packing material? And the second question is, did you try to correlate your data with data about the pathogens? Because this would give a hint if the minced meat is still safe to eat or not.
Okay, thank you. So actually, to answer the first question, we did not scan through the vacuum. We just minced it and then did extraction. But it's a good idea, and then we would probably consider it when we start the main experiment. Yeah, but because we scanned through the vacuum, but it wasn't with meat. We did that for like some other samples, but we didn't really consider this now. And I'm happy that you brought it up. About the second part, to see whether meat was still safe to consume. Actually, when we were planning this preliminary study, we didn't really focus much on the safety of safety for consumption, where we were more interested in to see if NIR could first of all, and Aquaphotomics could first of all discriminate or detect these differences in mixtures. But eventually we would capture the safety part as well, because that's the most important.
Yeah, because there is a lot of going on with falsification of expiration dates, and this very often causes huge problems. Therefore, such a method could really be extremely helpful.
Okay, yeah. Thank you. Thank you very much.
Thank you.
If I can add, it should be dependent very much on the expiration date. So when you do the measurement of the meat, when you have to classify the meat, you have to know the expiration date. So there are two topics, one above the other. Just one question. How did you do this raw meat extraction? What does it mean? How did you extract water from raw meat?
Okay, so so for the raw meat extraction, it was like just a crude method. We're just curious to see if it's possible, because we know that probably because of the lipids and the fatty nature of the meat, it would probably not work. But interestingly, it gave us good results. And what we did was that, so we just, after we weighed the meat mixtures, we put them in the flask, as you can see in the over here. And then we just covered it, and then I homogenized it for like about 3 to 5 minutes. Then we just filtered it over here, and then we used this extract to prepare the 1% weight per volume dilution.
Yeah, thank you. Understood. Yeah, probably what Christian suggested. If you do a monitoring of the sample with the time, for example, if you measure today in the morning, in the evening, tomorrow, kind of you can get the line of adulteration by time. So then you can split out the identification of the adulteration coming from different meat and from time. But this is must do something. It's very interesting topic, very important. Yeah.
Thank you.
I have a question. Sorry, is it possible, John? Is are you available? So I found it interesting thing. So with every meat extraction, your algorithms. So starting, you have this pattern. For example, for the B90 for the 90%.
Yeah.
So you have the same pattern, which involves these two bands that I was, 2-3 bands that I was mentioning today about the stronger bound water and this dehydration band. So the stronger bound water, their pattern, this pattern presents the damage, and for the same percentage in the non-extracted meat, you have beautiful salvation. So I don't understand what Professor Tenkova, what extraction basically does compared to the non-extracted. It's can you explain what this filtration is doing?
Okay, so basically the extracted samples were all extracted with water, but just different process. And one was raw, the other one was frozen, the last was cooked. But for the non-extracted, that is just the minced meat. After mincing, we mixed it, and then we just scanned the minced meat without any dilution or any extraction.
So that's minced meat.
Yes. So then non-extracted, that's meat itself, exactly. Yeah. So so basically we wanted to see whether because we were thinking that for instance, if the meat is already like the minced meat on the shelf, for instance, it will be probably, because of the homogeneity of the surface, maybe it may have the detection with NIR may have some limitations. But so we said that, okay, what if we dilute it? What if we do some dilutions and then see if maybe we could extract some meat compounds with the water, and then which could also help us to identify the mixtures.
Interesting approach. How to dilute meat.
It is very interesting that you get better prediction when you look at the water.
Yeah.
And this is something that got my attention. So very good. So this is the information. So you don't want the influence of the particle size of the meat or fat or whatever. You just want the water that brings the information for the meat. Beautiful.
Exactly. That's a general approach. Thank you.
Thank you.
Thank you. Do we have more questions or comments? okay, we might have had problem with downloading your poster from the website. I see comment from here. I'm sorry. So
I was able to download it though.
Ah.
Yeah, from the website.
Well, I'm not sure. Only Pierre's reported he couldn't. Maybe it's something.
Okay.
So
thank you.
Thank you. Okay. Other people could download it. Sorry. So it was fine. Pierre had problem. It was really interesting about your results and what Pierre said about biocoherence. I relate that to the talk of Professor Dr. Tonauer and these different types of ICs. Finally, I connect. I wasn't aware that. So I don't have any more questions or comments except to say that this was really, really beautiful and interesting. And I must say, improvised poster session a bit. So I'm very grateful to all of you who attended the discussion, and actually a lot of people stayed. We're still around 50 people, right? And I want to repeat, please vote for the best posters in your opinion. Please download them from the page, look at them from the conference page, and let's meet tomorrow. That means in 12 hours to say good morning to Professor Shaw and to say good night to Professors Jorge Vence and Anibal Di Salvo from America. They're just going to continue along this direction.
And finish being very positive and thankful to Corona. So if there is no Corona, we would never had such a beautiful discussion.
Yeah.
Yes, absolutely.
So then with this, I conclude this day of the conference, and let's meet tomorrow morning, sharp 9 o'clock. Good night to everyone in Japan.
Yes,
good morning and have a wonderful day in Europe. Bye-bye. Yeah, just like Eurovision. See you, Vlada. Bye-bye.
Ciao, Yellow. Completely like Eurovision. Yeah.
Completely.
Have a nice night. Enjoy. Thanks.
You.
Bye-bye.
Bye-bye.